Okay, let's take another example here. Let's use our notation now, our new notation. We're going to find the integral of x plus 3. Okay, this is the integrand in here. And we have our notation to indicate that we're doing anti-differentiation here. Okay, so it's anti-differentiation. All right, so we take one term at a time. We would say, okay, this first term must be x squared over 2. The second term, a 3x would do the job. And then don't forget to throw in a constant of integration. Now, how do you know you have the right answer? You can differentiate it to c. Go ahead, differentiate it, and you'll see that, yes, it is x plus 3. So that's all that is proof enough that you have the right answer. So now you don't have to do that, but in the early stages here, you might want to try it just to be sure that you are on the right track. Okay, next problem. These are short. Okay, this one, we don't really recognize it, but usually we can do a rewrite. Okay, in other words, we have x over root x and a 2 over root x, like that. So I'm going to write this first term as x to the 1/2. And it's simplified, and this will be 2x to the negative half. Now, I'm going to work backwards again using the power rule. I'm going to say this must have been x to the 3/2 divided by 1/2, which would have been a 2 in front. So now if you were to, well, 2/3, sorry. I meant to say this would be x to 3/2 divided by 3/2, which is the same as times 2/3. Now, if you do a quick check, backwards check, differentiating this expression, you would see the 2/3 cancel with that power. The power would come down to 1/2. Therefore, you have the right antiderivative. The next one, you're going to add 1 to that to make it a 1/2, and then divide by 1/2, which means you'll have a 4 here. And don't forget the constant. Now again, double check your work. If you differentiate this second term here, you'll bring down the 1/2 out in front. That'll make that 4 times a 1/2, which is 2, and then the lower down to a negative 1/2. That's it. So you know that you have the right answer. So think about that a little bit, and we'll move to that next example on the next problem.